Hey, are you ready to tackle some percent change tonight? I hope you're ready to rock and roll. We've been building up and building up and building up. We've been working really hard on all the properties of our exponents. We started just by reviewing some general properties from Algebra 1, and then we talked about how to handle negative exponents. We talked about how to handle fractional exponents. And then we got into a lot of this exponential growth and decay. We're going to continue to build on that with our focus being on percent change. Here's a really fun scenario to consider here. And let's talk about making some money, shall we? So let's imagine that you invested $12,000 or $2,000 to start with, and that account was guaranteed to grow 4% for each year over the course of 10 years. What percent growth should you expect to see by the end of that 10-year period? Now, I think our intuition tells us it should be 40%. We'll just multiply the 4% by the 10, and that should come out to be 40%. Well, I've got good news and I got some bad news. First, the bad news. Unfortunately, percents don't work that simply. It's a little more complex than that, and that's what we're going to dive into. But the good news is you're going to be making more money than you expected. So let's take a look. So let's see if we can figure out exactly what the percent change is going to be over that 10-year period. So we're thinking our exponential model, anytime there's some type of percentage involved, is going to be a times b raised to the t power. And that b is going to be either 1 plus r or it's going to be 1 minus r. So I'll put a 1 plus or minus r there. So we've got our $2,000 and we're guaranteed to get 4%. And we're going to try to figure out how much money we've got at the end of 10 years. So let's go ahead and plug this into our calculator. And I'm just going to round it to the nearest dollar just to keep our job as simple as possible. So I think our $2,000 has grown into about $2,960 just by letting it sit in this account and grow. So how much did we gain? Well, let's going to say we're going to take our new value. We're going to subtract the old value and then divide by that old value. And that's going to help us determine our percent change. Okay, so I've got my 2960. I'm going to subtract my 2,000, and then I'm going to divide that difference by 2,000. And I got 0.48, which is equivalent to 48%. Okay, so isn't that wild? Like, we were kind of just thinking it was going to return about a 40% return on our investment. In fact, it's going to return about 48%, which is really good news because we're going to have more money than we were initially expecting. So we're going to gradually dive in and see, like, how does that actually happen? How does that actually happen? So anyway, let's just focus on finding some percent change given some generic numbers here. So all we're doing is we're taking our new value, we're subtracting our old value, and then we're going to divide by that old value. So we'll get this little formula in our notebook. And let's say we started off with $250 and a year later it grew to $330. So we're going to take that $330, we're going to subtract the $250 and divide by $250, and let's see what we get. All right, that gives me 0.32 or 32% increase. All right, now you'll notice on this next one, we got to be really careful. We started at 98 and a year later we dropped to 74. So we definitely lost money on this particular investment, unfortunately. So we're going to see a negative percent change. So let's go 74 minus 98, okay, and divide that by the original or the old one. And evaluating that in my calculator is going to give me about negative 24% is going to be our change. All right, last one here. We'll go 1638 minus 1284 and then divide that by 1284. Okay, that's going to give me about 28% increase. All right, that's a pretty good year. If we're talking money, we'll take that any day of the week, huh? All right, so just some general broad things, depending on the task at hand, and we're going to get really, really good at writing exponential equations, okay? And one other comment here before we really dive in, when they ask, what should you multiply by, really what they're asking us, what is our value of b? Okay, what is going to be the b value in terms of our exponential equation? So if we want, and basically that b value, it's always going to be 1 plus r or minus your r. So in this first one, if we're going to increase by 5%, 1 plus 0.05, in other words, we're going to multiply by 1.05. If we're going to decrease by 5%, now we're going to subtract, and it's going to be 0.95 is our b. increase by 24%, or we could decrease by 24%, okay? So I'm either just adding it to 1 or subtracting it from 1. All right, if we increase by 8.351, we're going to go 1.08351. Or we're going to subtract. I'm going to have to show a little bit of scrap work here. Don't forget to move sometimes we just move the decimal place once on accident. We want to make sure we always move it twice. And I am definitely going to my calculator for this one. Unfortunately, I'm kind of wimping out here. We're going to get 0.91649 is going to be our B value. Okay, now don't forget, we got to move this decimal twice, right? So count your zeros very carefully. 1, 2, 3, 4, and then the 4, 5. Okay, or in this case, we've got to subtract 0, 0, 0, 0, 4, 5. I'm going to go to my calculator. 0, 0, 0, 0, 4, 5. I've got 0.999955 is going to be my base value. All right. Now we're going to work backwards here. So if I told you that you had a base value of 1.983, you kind of have to reverse that process. Okay. Think about going backwards. And we're going to say we're increasing by 98.3%. Okay. Now, if you need a little bit of guidance on that one, just imagine, we know that B equals 1 plus R in this case. So imagine taking that 1.983 and setting it equal to 1 plus R. So by the time you subtract the 1 over, you're going to get 0.983. And then you just got to remember to move the decimal place twice. All right. Now, this next one's much, much harder for me to do in my head. So I'm just going to really trust the process. And we know that B equals 1 minus R. So we know that 0.6183 equals 1 minus R. I'm going to add an R from the right to the left. And then I'm going to subtract over the 0.6183. And let's see, 1 minus 0.6183. I'm getting R equals 0.3817. Don't forget to move the decimal twice. So we are decreasing at a rate of 38.17%. How about that? How about that? Okay, some other verbiage that we may say. So when they say something's doubling, we doubled our investment or we doubled the population of bear cubs or whatever. If you're doubling, you think about it, you're increasing by 100%. In other words, your R is gonna be 1 plus 1.00, so you're gonna multiply by 2. You're gonna have B equals 2. Whoops, I screwed that up. That should be a B. I'm sorry, that should be a B. So we'll make that edit in our notes there. Okay, if we triple something, we're actually increasing by 200%, believe it or not. So your B value is going to be 1 plus 2.00. In other words, B is going to be a 3. Well, now that part makes sense. You may say, you know what, I'm not sure why we're increasing by 200% if you're tripling it. But the fact that B equals 3 when you're tripling it or B equals 2 when you're doubling it, that certainly makes more sense to me. Now, what if I'm quadrupling? You're actually increasing by 300% technically. So your B value is going to be 1 plus 3.00, or in other words, B is going to be a 4. What if you just want half as much? What you're really thinking is we're decreasing by 50%. So we're going to go 1 minus 0.5. In other words, B equals 0.5. We want to increase the original amount by a quarter. Now, maybe what you want to think is just think about converting that 1/4 into a decimal. So that's going to be 0.25. Okay, so you want your base to be 1.25. One way to think about this is when we say 1 plus 0.25, you're thinking, okay, the 1 represents everything I've got up to this point, and then I'm increasing, by a quarter or, 25%. Let's see, the next one, we're going to decrease by a quarter. So we'll get a base of 0.75. Let's see, what else we got. We're going to increase by 2/3. So we could think of that as 1 plus 0.66 repeating. So your base is just going to be 1.66 repeating. And then, or we could decrease which is going to give us 0.33 repeating. All right, working backwards here. If I see a base value of 1.4, okay, that means my R must have been a 0.40, or you could say I was increasing by 40%. Or if you convert the 0.4 to a fraction, another way to say that is you're increasing by 2/5 of the original amount. Okay. Now, if we're going backwards here, again, 0.60 could be equal to 1 minus R. And when you solve for R, you're going to get that 0.4. But this time you're decreasing. So we're decreasing by 40%. Or another way to say that is we're decreasing by 2/5 of the original amount. Okay, here's my favorite part of tonight's topic. So we're interpreting these tables and we're trying to find the percent change so that we can eventually write an equation, or the exponential function. So right out of the gates, my initial value here, initial means just go right to the 0. You're thinking x or t equals 0. So in this case, the initial amount is 80. Now here's the percent change. And technically, you should be able to pick any consecutive pair of points you want. I'm just going to pick the first two because they're the easiest. And remember, it's new minus old divided by old. All right, let's type that bear into the calculator. So we've got ourselves 98.4 minus 80. And then we'll divide that answer by 80. So I got 0.23. So we got 23%. All right. And my function is going to be y equals 80. And then parentheses, 1.23 raised to the t or the x. All right. And of course, those numbers were getting bigger. We went from 80, we jumped up to 98.4, we jumped up to 121.032. So anytime you're jumping up, we're certainly expecting that base to be bigger than 1, or else something went drastically wrong. All right, what's your initial value here? It looks like we got ourselves a nice 92, but you will notice that the values are dropping, right? We're dropping. So we've got a negative percent change, or our base is eventually going to be less than 1. For that percent change, you can pick any consecutive pair of points you want. So we'll go 80.04 minus 92, divide the whole thing by 92. 80.04 minus 92. Divide that by 92. So I'm going to get negative 13%. Oops, we've already moved the decimal. All right, because that was negative 0.13, and so we'll need negative 13%. So as a function, I've got 92 and then 1 minus 0.13 raised to the x. Or in other words, let's see, that's going to be 0.87 if I subtract them. Cool beans. All right. Mr. Krangle bought a brand new Jeep. How exciting is that? And now he knows the value of his Jeep will depreciate. Okay, this is a good rule of thumb. It's going to depreciate about 12.35% each year. And after 6 years, it is going to be worth about $12,500 when he trades it back in to get his next new Jeep. All right. Can we figure out what the initial value of his Jeep must have been? All right, so let's think about what we know. I think we've got enough information to pull this off. Imagine starting with this framework in mind, right? And so the one thing that's unknown is the A. That's what we're looking for, the initial value. So hopefully we've got some numbers that we can plug into every other spot. All right. So right off the bat, I know my base is going to be 1 minus 0.1235 because we're decaying or depreciating. And I know that after 6 years, it's worth $12,500. So what I'm going to do here in an effort to solve for A is I'm going to plug all of this part into my calculator. And let's see what that gives me. All right. 1 minus 0.1235. We'll raise that to the 6th power. Okay, very, very long decimal, but I'll do my best to write it out so you got an idea if you're on the right track. It's about 0.4534313279, and then we're just going to divide that number to the other side. So we're just typing in 12,500 divided by that big crazy number. And I like to just hit second answer. So I don't know if you noticed above the negative sign, if you hit second negative sign, it just imports your previous answer. So you don't have to type in all those decimals. And so I got the initial amount to be 27,567.57. Or if we go nearest dollar, we'll say $27,568 was his initial cost. When is the Jeep going to be worth 40% of its original cost? So 40% of 27,568 is going to be 0.4 times that original value. Okay, so let's go times 0.4. So I got about $11,027. So in other words, another way to think of this question is, when is the Jeep going to be worth $11,027? So let's substitute that for our output or our Y value. We know the initial cost, 27,568. We know it's going to depreciate at about 12.35%. And now I'm just going to try to solve for T. And probably what we're going to do today, because we haven't learned how to do logarithms yet, is we're going to focus on graphing these and finding an intersection, okay? Now, one thing you can do to maybe make your life a little easier, just because so the window's not as obnoxious, is we can divide both sides by that 27,568. So let's go ahead and try that. Let's divide by 27,568 so we can cross those off. Ironically, that's going to give you the 0.40. Let's see, what is 1 minus 0.1235? About 0.8765. All right. So what we're going to do is let's graph this as one function. We'll graph this as another function, and we'll see where they intersect. All right. And I'll try to draw a little picture. Now you'll notice when you graph that 0.40, it's going to, I'll do that one in orange. It's just going to shoot a line straight across, and your Y max only needs to be about a 1. Okay. So let's see what happens. And then let's see if we'll graph this next function in green, and it kind of came down through 1 and they intersected. I did have might have to play with your window. My X max was 10. My Y max was, 1 or 2. It was more than enough. And my intersection came out to be about 6.9511,504. And then you could just round that to the appropriate place. I'm going to guess they'd probably go like nearest to 100. So we'd say about 6.95 years, or right around that 7th year is when the vehicle's worth 40% of its original cost. All right. Hey, nice job, guys. Way to hang in there tonight on a very challenging topic.